Hi students, welcome to another episode of All 4 e-learning program. Right, this is physics session number 14. Now in this session we will learn about, we'll have a glance over the applications of electric dipole. Let us learn all the applications of electric dipole. Right, so before going to this, just have a preview. Charge, a fundamental quantity. Right, charge exhibits field around itself, electric field. It shows electric force, Coulomb force F proportional to Q1 Q2 by d square, right? And field, electric field strength is the force experienced by unit positive test charge. And the electric lines of force, electric line of force is the path along which a unit positive test charge would tend to move. Now, in the previous episode, we were learning about electric dipole. A dipole is a combination of two equal and opposite charges separated by a small and a finite distance between them, right? And dipole, the characteristic property of a dipole is a dipole moment, electric dipole moment. It is the product of either of the charge, any one of the charge, the magnitude of the charge, and the distance between the charges. So dipole moment is the product of any of the charge q and the distance between the charges. This is dipole moment measured in Coulomb meter, right? It's a vector quantity. Now coming to the applications. Now dipole moment. Suppose if there are two dipoles minus q plus q is one dipole P1 bar. And there is another dipole, let's say minus q1, this is q1, this is minus q2 and plus q2. This is P2 bar. If there are two dipoles inclined at an angle theta like this, right? Then what is the resultant dipole? Now dipole moment is a vector quantity, combination of two vectors according to parallelogram law of vectors. When two vectors are represented as two sides of a parallelogram, the diagonal passing through them represents the resultant vector. So the magnitude of the resultant is root of a square plus b square plus 2ab cos theta. So therefore magnitude of the resultant, if I complete the parallelogram like this, now this is the resultant dipole moment PR bar. So therefore resultant dipole, magnitude of the resultant dipole moment under root of P1 square plus P2 square plus 2 P1 P2 cos theta. If two dipoles are inclined at an angle theta, then the dipole moment is a vector, should add them vectorially. So according to parallelogram law of vectors, so the resultant vector, if two vectors are represented as two adjacent sides of a parallelogram, then the diagonal passing through them represents the resultant vector. So the resultant dipole moment, it is a square plus b square plus 2ab cos theta. So P1 square plus P2 square plus 2 P1 P2 cos theta. This is the magnitude of the dipole moment. And what is the direction of the resultant dipole moment? Alpha. So the direction tan alpha, the direction of the resultant dipole moment tan alpha is given as P2 sin theta by P1 plus P2 cos theta. The direction of the resultant vector, the angle made by the resultant vector with P1. So alpha is the angle made by the resultant with P1. Then tan alpha. P2 sin theta by P1 plus P2 cos theta. This is the direction of the resultant dipole moment there. Okay. Now taking the cases, various cases. Case 1. If these two dipoles are parallel, in the sense, first dipole P1 bar and another dipole is P2 bar. So I was telling you a dipole, a short dipole is represented by a bold arrow, right? First dipole is P1 bar, second dipole P2 bar. Then the resultant dipole moment, the magnitude of the resultant, both are parallel, theta 0, cos 0 is 1. So it is a square plus b square plus 2ab. It is a plus b. So it's simply P1 plus P2. And the resultant dipole moment will be having the same direction as this. The resultant dipole moment also has the same direction like this. Second case, case 2. case 2. Suppose if these two dipoles are in opposite direction, angle theta 180 degrees. So one dipole this side, other dipole this side. It's P1 bar and P2 bar in opposite direction. Then the magnitude of the resultant dipole, it's theta 180 degrees, it is angle 180, cos 180 is minus 1, so it's P1 square plus P2 square minus 2 P1 P2. A square plus B square minus 2AB, cos 180 is minus 1, so then we'll get P1 minus P2. This is the resultant dipole moment. Now, what is the direction of the resultant dipole moment in this case? In this case, out of P1 and P2, the dominant dipole moment, whatever exists, out of these two, whichever one is dominant, the resultant dipole moment will be in the direction of that dominant. Suppose if P1 is greater than P2, the resultant will be along P1. If P2 is greater than P1, the resultant will be along P2. So resultant dipole moment direction will be in the direction of the dominant electric dipole, P1 plus P2. Similarly, suppose if these dipoles are perpendicular to one another, if they are perpendicular, if theta is 90 degrees, they are perpendicular to one another. One dipole is like this, other dipole this way. This is P1 bar and P2 bar, angle 90. They are at 90 degrees, right angle to one another. Then what is the magnitude of the resultant dipole moment? So it is root of P1 square plus P2 square plus 2 P1 P2 cos 90. Cos 90 is 0. So this is 0. So therefore, it is equal to under root of P1 square plus P2 square. This is the direction of this is the magnitude of the resultant dipole moment when they are perpendicular. So when these both are perpendicular, the resultant dipole moment will be in this where the angle is alpha. Then tan alpha is given as P2 by P1, magnitude of P2 by P1. Now alpha is the angle made by the resultant dipole moment with the first vector, first dipole. Magnitude is root of P1 square plus P2 square when they are at right angle to one another. So when two dipoles are in same direction, they add up. So both dipoles add up, they become stronger, the dipole moment is maximum. Both add up algebraically, you will get maximum dipole moment here. Dipole moment is maximum. When two dipoles are arranged in same direction, parallel, they are like vectors, then theta 0, then the net dipole moment is maximum. It's P1 plus P2, highest dipole moment. Now when these two dipoles are in opposite direction, they are in opposite direction like this, unlike vectors, theta 180, then the net dipole moment is minimum. They nullify one another. Here they add up one another. When they are in same direction, they add up one another. They are aiding one another, supporting one another. So you get maximum. But here they oppose one another. They are opposing, they are separating, they are nullifying one another. So you get the minimum dipole moment. Dipole moment is nullified. The dipole moment of one is nullified by the dipole moment of the other. The net dipole moment decreases, it is less. And if they are perpendicular, right, this is called perpendicular dipole. The net perpendicular dipole moment, when they are, it is root of P1 square plus P2 square. According to Pythagoras theorem, the net dipole moment is found as root of P1 square plus P2 square. The direction is given as like this. If suppose in this one, another special case, suppose if there are two dipoles, there is one dipole P and another dipole also same P of same magnitude, two identical dipoles separated by an angle theta, inclined at an angle theta. Two identical dipoles of same dipole moment, if they are inclined at an angle theta, then the net dipole moment is. So we will evaluate the formula for this. If they are in same identical dipole moments, then what would be the net dipole moment when they are inclined at an angle theta? Suppose if two identical dipoles, same dipole moment P each, are inclined at an angle theta. right? So completing the parallelogram like this, the resultant dipole moment is PR. Two identical dipoles inclined at an angle theta like this, then if suppose there are two identical dipoles of same dipole moment P each are inclined at an angle theta, right? Two dipoles like this PP are inclined at an angle theta, right? Shown by two adjacent sides of a parallelogram. Suppose if I represent them as two sides of a parallelogram, then the diagonal passing through the point of intersection represents the resultant vector. So this is P, angle theta, then the resultant dipole moment P at an angle theta like this. Then now the resultant dipole moment is given as P resultant is, according to parallelogram law of vectors, we know R is equal to root of A square plus B square plus 2AB cos theta. But here A magnitude and B magnitude both are same, PP. So substituting, I get under root of, so here it is P1 is P, P1 magnitude is P, and P2 magnitude is also P. Two dipoles of same magnitude P each. Then, so it's P square plus P square plus 2PP P square cos theta it is. So therefore the resultant dipole moment magnitude will be root of P square it is 2P square plus 2P square cos theta. This is the thing, right? So therefore resultant dipole moment, the magnitude of the resultant dipole moment is 2P square common, it is 1 plus cos theta. According to trigonometry, we know 1 plus cos theta is 1 plus cos theta. It is 2 cos square theta by 2. It is 2 cos square theta by 2. So trigonometry, applying this in this. So therefore, the resultant dipole moment is equal to, it is under root of 2p square of 1 plus cos theta, that is 2 cos square theta by 2. So the resultant dipole moment is under root of 2 into 2 square p square cos square theta by 2. Square and root, removing the square and root, the resultant dipole moment is 2p cos theta by 2. This is the magnitude of the resultant dipole moment. If two electric dipoles of dipole moment P each, both same P each, are inclined at an angle theta, then the resultant dipole moment is 2p cos theta by 2. P is any one of the dipole moment, theta is the angle between them, So this is the magnitude of the resultant. Now how about the direction? So the direction, if this is one dipole and this is another dipole P and P, and this is the parallelogram, then the resultant dipole moment is the angular bisector of this total angle. The total angle is theta. The resultant dipole will be the angular bisector. It is theta by 2 here and this is theta by 2 here. It is the angular bisector of the two dipoles. Along the angular bisector, the resultant dipole moment will be along the angular bisector. So, two identical dipoles P each inclined at an angle theta, right? Then the resultant dipole moment is 2p cos theta by 2, and the direction of the magnitude of the resultant is 2p cos theta by 2, and the direction of the resultant dipole moment is the angular bisector theta by 2 and theta by 2. This way it is. Now in this one, suppose if in this case, if we consider if two dipoles are one over the other like this parallel, two dipoles are along same direction, identical dipoles PP parallel to one another, then the resultant dipole is, both are parallel, theta 0, same direction. So theta 0, cos 0, 0 by 2 0, cos 0 is 1. So therefore it is 2p. Both add up to double the dipole moment. Suppose if these two dipoles are in opposite direction, P and P, both opposite, unlike, They are in opposite direction. Angle 180 degrees. Cos 180 by 2. 180 by 2 is 90. Cos 90 is 0. So the resultant dipole moment is 0. So when two dipoles are in opposite direction, equal and opposite, equal magnitude in opposite direction, they nullify one another, cancel one another. Net dipole moment is 0. Similarly, if two dipoles are at right angle to one another, P and P at right angle to one another, two identical dipoles at right angle to one another, then the resultant, the magnitude of the resultant dipole moment is, magnitude of the resultant dipole, theta is 90, cos 90 by 2, 45, so it is 2p cos 45. So it is 2p of, we know cos 45 is 1 by root 2, and 2, this 2 I can write it as root 2 into root 2p into 1 by root 2. So 1 root 2, 1 root 2 cancel. So therefore the resultant dipole moment is root 2 times p. It is root 2p. So when two identical dipoles are perpendicular, right angle to one another, the net dipole moment is root 2 times p. And the direction here, it will be angular bisector, 45 degrees, equally inclined to both the dipoles. It is equally inclined to both the dipoles. Here both are in same direction. The resultant dipole is 2p. The direction will be in the same, like this. Here two identical dipoles opposite nullify one another, it's a null vector 0. And here perpendicular to one another, the resultant dipole is root 2p, equally inclined to at 45 degrees to both the things. So this way, when two identical dipoles are inclined at an angle theta, then the resultant dipole is given like this. The magnitude of the resultant dipole is 2p cos theta by 2. The direction is the angular bisector theta by 2. And if two identical dipoles are same direction, maximum 2p. Opposite direction, then nullify. Perpendicular, it is root 2p, like this. Okay, thank you. And another simple question based on this dipole. Suppose a electron and a proton are separated by a distance, let's say something like 1.6 into 1.6 angstroms. Imagine like 1.6 angstroms. Then what is the net dipole moment of the combination? An electron and a proton are separated by a distance of 1.6 angstrom. Then the resultant dipole moment is the dipole moment. According to the definition of dipole moment, it is a product of either of the charge and the separation between them. So either of the charge, electron, charge of electron, charge of proton, both we know, both are equal to 6.02, 1.602. 1.602 into 10 power minus 19 coulombs. So either of the charge, so it's q into distance between the charges. So therefore P bar is equal to magnitude. It's 1.6 into 10 power minus 19 into distance between them is given as 1.6 angstroms. Angstrom is a small, very small unit. So converting into SI system, it is 1.6 into 1 angstrom is 10 power minus 10 meters. Right? So substituting the distance is 1.6 into 10 power minus 10 meters. So it's 1.6 into 1.6 into 10 power minus 19, 10 power minus 10. So come on, simplifying the thing. 1.6 into 1.6 is 2.56 into 10 power minus 19 minus 10, it is minus 29. So the dipole moment of the combination of an electron and a proton separated by a distance of 1.6 angstrom is 2.56 into 10 power minus 19 coulomb meter. Now we have taken the example as an electron and a proton. Instead of electron proton, suppose if he gives you a molecule of singly ionized positive ion, singly ionized negative ion, like let us say NaCl, sodium chloride, Na plus, and it is Cl minus. So this is positive, this is negative. Even though sodium has got atomic number bigger atomic number 11, but the net charge is only 1 unit positive charge. So it's plus E. Chlorine, of course, the atomic number is 17, but 1 unit negative charge, minus E. So even though the elements are different, it is same as this. It is the combination of one electron and one proton. One electron, one proton separated by distance. The value will be like this one. the atomic, the length of the bond length you should take. The bond length will be the distance between the ions, that is the length of the dipole, and the net charge, sodium positive ion, it is 1 unit positive charge, that is 1 electron, value magnitude 1 electron charge but positive. Chlorine negative ion, even though the atomic number is different, the net charge is minus E. So this is a proton electron combination, it is same as this problem, right? So this way the dipole moment of the combination of an electron proton, 1 unit charge is separated by some distance. Now suppose if he asks you to find the dipole moment of a molecule, then the molecule before forming the ion there, what net charge this positive ion and the net charge of the negative ion, the distance between them is the bond length. The bond length will be the distance between the ions there. That will be the length of the dipole, the product of the net charge and the length of the dipole. That gives you the electric dipole moment of the system. In another question, 3 charges are arranged on the vertices of an equilateral triangle of side A. There is an equilateral triangle of side A. This is plus Q charge. This is also plus Q charge, but this is minus 2Q charge. 3 charges are arranged on the vertices of a equilateral triangle of side A like this. On 2 vertices plus Q, and the other one it is minus 2Q. He is asking to find the net electric dipole moment of this system of charges. Net dipole electric moment of this system of charges. Now how to do this problem? First, let us consider each dipole separately. He has given a combination. So minus 2Q. Let me imagine this as a minus Q charge and a minus Q charge. Forget this. Considering this plus Q, if I consider only a minus Q charge, minus Q plus Q, this forms one electric dipole. So the direction, this is one electric dipole, let's say P1 bar. One electric dipole P1 bar. So the magnitude of electric dipole P1 bar, it is either of the charge Q and the distance between them, that is E, P1 bar. Now, forget about this charge, take this combination. It is plus Q and this is minus Q. Now this combination again is an electric dipole. Let the dipole moment is P2 bar. Then the magnitude of P2 bar is again the charge into distance between the charges. Either of the charge is Q, distance between them is E. Now there are 2 dipoles P1 and P2 inclined at an angle. Given it is an equilateral triangle. We know in an equilateral triangle, the angle between the sides is 60 degrees. Therefore, now the resultant dipole moment, according to parallelogram law of vectors, the magnitude of the resultant vector is given as root of a square plus b square plus 2ab cos theta. So it is root of p1 square plus p2 square plus 2p1 p2 cos theta. Actually, the resultant dipole moment is root of p1 square plus p2 square plus 2p1 p2 cos theta. But when you observe the values here, the magnitude of P1 and magnitude of P2 both are same. So here mod P1 and mod P2 is P. So therefore the resultant magnitude, the resultant dipole moment is under root of P square plus 2P square cos theta. We have just now evaluated this as 2P cos theta by 2. 2p cos theta by 2. So therefore, the resultant dipole moment of this combination, is equal to 2p, either any one of the dipole. So any of the dipole moment qa times cos of the angle between the dipoles is 60. It is 60 by 2. So therefore, P resultant is equal to, it's 2qa, cos 60 by 2 is cos 30. So therefore the resultant dipole moment mod PR is equal to 2qa. It's 2qa cos 30, it is root 3 by 2. So therefore the magnitude of the resultant dipole moment is root 3qa. This is the resultant dipole moment of this system of charges, right? Magnitude of the resultant of dipole moment. Now what the direction? This is one dipole P1, other dipole P2. If these two are considered as two sides of a parallelogram, then the resultant is the diagonal passing through the point of intersection. Again, since the magnitudes are equal, when magnitudes are equal, then the resultant vector will be the angular bisector. So the resultant dipole is the angular bisector. This is 30 degrees and this is also 30 degrees. So the resultant dipole has a magnitude root 3 QA and it is an angular bisector equally inclined to both. So the magnitude and direction. This is a problem. It's a problem given in general as charges. But if you go deep inside, this is a molecule. A molecule with two unit charges and a double charge here. Example, water molecule. If you consider water molecule, so this is H2O, H and H like this and oxygen. So this is one dipole and this is another dipole inclined at an angle. So for that the resultant dipole moment is like this, right? It's a quadruple. It is indirectly a quadruple. He is asking to find the net dipole moment of a quadruple, right? So it is given in general. The problem is given like as if it is a different problem, but we have to make out that this is similar to a quadruple. It is similar to a oxygen molecule. Sometimes he'll even give you like this. Suppose same question. A system of three charges like this. This is minus 2q, this is plus q and plus q. Right? Now the angle is obtuse angle. Earlier we have taken acute angle. Now the obtuse angle. Let the angle between them be 120 degrees. Now the question is given like this. He gives you in general as if it is a different question. A system of three charges is as shown like plus q at the ends and both combined to minus 2q inclined at an angle 120 degrees. What is the dipole moment of the combination? So if you consider it as two dipoles, let me take instead of 2q, let me take it as a combination of minus q. Forget this charge. Minus q plus q. This is one dipole P1. One dipole P1. The side, he has given the distance also. Side is A. So it's q into, let the distance be D. Q into D like this. And its direction is from minus to plus P1 bar. This is another dipole P2, right? Again, the charge is q, distance is D. It is q into D in this direction. Two dipoles inclined at an angle theta. One dipole in this direction, the angle is obtuse angle. We know according to the resultant dipole, it is under root of P1 square plus P2 square plus 2 P1 P2 cos theta. So since the magnitudes are equal, mod P1 is equal to mod P2 is P, then the resultant magnitude is 2P cos theta by 2. The resultant magnitude is 2P cos theta by 2. Theta is the angle between them. Angle is 120 degrees. Both having same magnitude, QA and QD. So therefore, the resultant dipole moment is 2. Magnitude of any one of the dipole, it's QD into cos of 120 by 2. So therefore, the resultant dipole moment is 2QD cos 60. But we know cos 60 is 1 by 2. So cancel. It's Q into D. So the resultant dipole moment of this combination, is QD same as that of the either of the dipole moments. So it's same as mod P1 or mod P2, same as mod P1 and P2 like this. So when the angle is obtuse angle 120 degrees, the dipole moment is like earlier we have taken when these two dipoles are arranged at an angle of 60 degrees, we got the answer as root 3 times QD, root 3 times P it is, right? So this way, when the angle between them is 120, it is QD, when the angle between them is 60, it is like this. Now he may combine the both problems together. When there are two system of charges like this, minus 2Q plus Q plus Q. This net dipole moment is P1. Another system of charges plus Q and this is minus Q. The net dipole moment is P2. Now he will ask you to compare P1 and P2. Compare P1 and P2. So, system of three charges arranged on the vertices of an equilateral triangle here. Equilateral triangle, right? This is an equilateral triangle with angle 60 degrees. Same charges with angle 120 degrees. Now he is asking you to compare the dipole momentum of this set of charges and this set of charges. We have just now proved when three charges are arranged on the vertices of equilateral triangle, consider as two dipoles, one dipole here with 60 degree. We got the dipole moment as root 3 times P, each dipole moment. Now similarly, when the dipoles are arranged at 120 degrees, this one, when dipoles are arranged at 120 degrees like this, then the resultant